Hey folks, you ever do that experiment thing where you're like, I'm gonna take some vinegar, I'm gonna take some baking soda, I'm gonna put them together and it's gonna get all bubbly and I'll be like, I'm a scientist. I hope so, because that's some basic science. But you ever wonder what the heck is really going on there? Because really, at the end of the day, all chemistry has to do with electrons moving around. So I want to tell you what's going on with the electrons moving around when we have a reaction between the fabulous vinegar and baking soda. So let's take a look at these molecules for starters. Over here I got my guy vinegar, aka acetic acid, and you can see, yeah, it's a molecule. It's got some carbons, some hydrogens, I can't point stuff, hydrogens, oxygens, more carbon, but the part that we really care about is the part that makes it an acid, and that's going to be the part of this carboxylic acid functional group. That's going to be this hydrogen here, right here. Wow, this marker sucks. That's going to be this hydrogen right here. Wow, this marker also sucks. Time out for some more markers. I got more markers. Now I can circle this thing. So this is the hydrogen that we really care about. This guy is our acidic hydrogen. And we can think of that dude as more or less being, come on. We can think of that as more or less behaving as an H+, a hydrogen atom with a positive charge. Very nice. And things with positive charge, well, they're going to be attracted to things with negative charge. And you may notice, holy crap, look at that, look at that. Negative sign, little negative sign. Yeah, there's going to be some attraction between those two butt faces. The first thing that's going to go down in this reaction is one of these lone pairs of electrons. If you don't know what a lone pair of electrons is, just shut off this video because it's not going to make any sense to you. But if one of these lone pairs of electrons comes over and it can be like, yo, what up, hydrogen? I'm going to grab you. Now you may say, wait, there was a bond right here, and that's also made up of lone pairs. Yeah, well, that bond is going to break. Yes, that bond is going to break, and those electrons are going to go back onto that oxygen. This is the first step in the mechanism of our reaction. Electrons are moving around. They're moving from our baking soda, our sodium bicarbonate, and they're going to be flowing on over to our acetic acid and grabbing that hydrogen. And now is where stuff gets really interesting, because now, oh wait, I skipped a step here. I skipped a step. I skipped a step? Yeah, let's go back and look at that other step. Haha, I skipped a step. So here's that step. What's gonna start off with this acetic acid? Did you seriously just call that acetic acid? That's really? Bicarbonate! It's gonna go ahead and it's gonna grab two separate hydrogen atoms. And I've just kind of liberated those hydrogen ions so that they're by themselves. But one of our lone pairs of electrons is gonna be like, yo, what up? Wow. And that's gonna form a bond. Why don't we just go ahead and erase that ish? Get out of there, I don't love you anymore. And now we have a bond between those two goobers. Yes. And the same thing's gonna happen up top. These electrons are gonna go like, yo, what up? And they are gonna effectively form a bond. And so when those dudes fly away, we're no longer gonna have that negative charge, because I had a positive charge there. I erased it, but I have a positive charge up there. I haven't erased it yet. Good job, one guy. And so what we're gonna have is, if I had a negative charge and two positive charges, well, you might say to yourself, well, one of those sets is gonna cancel each other out, and then that positive charge is gonna be left over there. And that's exactly what we got. Let's fly the fork over here and take a look at this molecule. Yes, that is where the fun really starts. Once we have put two protons onto that oxygen from our sodium bicarbonate, now's when ish can really get popping. Really get popping, because now is when we get some more electrons flying around. You know, before it was just this oxygen being like, I'm gonna send my electrons out, they're gonna grab me some hydrogens. But now is where the party really gets started. I don't know if I can keep making this video. This is turning into way too much work. Yeah, let's finish it. All right, so we said the party's gonna get started. Take a look at this guy. We gotta get some electrons moving around. And one thing is, you may look at this and be like, bruh, that looks like some water to me. That's a H2O right there. And I would say to you, yes, you're right. We gotta get that ish out of there. So one thing is, this dude is ready to go on its own. That's a nice happy molecule on its own. It's gonna take these electrons from this bond and be like, peace, I'm out. But one thing is, this carbon is totally not gonna be stoked on that. And this carbon's gonna be like, if I'm giving up some electrons, I'll best be getting me some electrons from somebody else. And that's where this oxygen is gonna come into play, and it's gonna be like, hey boo, I got some of my own lone pairs of electrons, let me hook you up with that. And it'll be like, let's make this single bond a double bond and strengthen our love together. And what do we get from that? Here's what we get. We're gonna get that water that I done mentioned. And these electrons, after a skip hopping all over the place, that positive charge can't just go away. That positive charge is gonna get shuffle on over to this here oxygen, and we're gonna get pretty freaking close to some CO2. Check it out, it's like CO2, but then an H. We gotta get rid of that H. We gots to get rid of that H. Well, we're not gonna do it ourselves. What's actually gonna do it is that acetic acid way from the beginning. Remember that acetic acid? How it had this hydrogen ripped off of it, and the electrons, well, let's just, you know, this hydrogen got removed, and the electrons that were attaching that hydrogen, they got dropped onto this here oxygen. What that does is that gives this oxygen some negative charge because electrons have negative charge. And now this oxygen can be like, you know what, I kind of wish I had my hydrogen back. And so what it can do is take the marker cap off a red marker, and it can send a lone pair of electrons to grab that hydrogen. It can be like, come on, let's go. We're off on an adventure. Na, 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 wow. And it can grab that hydrogen. And that hydrogen, the electrons that are holding it on, now can go back. I switched to red at some point. At some point I switched to red. But those can go back onto this oxygen, and we can end ourselves up with a nice, let's just do it over here, happy CO2 molecule. And this, if you've ever done that baking soda and vinegar and wondered what the heck those bubbles are, well, it is CO2 gas being formed. And you're also making some water along the way. I wish I didn't suck at pointing to things. Jeez, well, that's the end of the video. Ta-ta, and have a great rest of your life. So, after looking at what I did there, I have some complaints. Complaints for myself. And, I've summarized those complaints over here on the husk of an old diploma. So, one thing is that I failed to really acknowledge the role of catalytic H2O in there at all. You may, if you're a good chemist, be like, bruh, where'd all the protons come from? And bruh, you reprotonated your acetic acid at the end, which would give you your product, or reactant as a product. So, yeah, there's some catalytic water in there that I totally ignored. Whatevers. You also may rightly have complained that I failed to note the positive buildup of charge on that carboxylic acid, carbonyl carbon. That guy right there. I chopped off the other parts. I chopped them off. Chop, chop, chop. And, yeah, you're right. I failed. And I also had a little fail here as I was working on this failure where I failed to note that the, hydroxyl group really is the one that directs the leaving of that H2O. Big old fails for wine grad. Whatever. That's whatever. I know. I failed. I suck. I failed and I suck. Whatever. Bye.